Hi, Jace.
and anyone else that may watch this eventually.
Oh,
All right,
yeah, that's true.
the integrated rate law. We had negative kt equals ln of at over a naught, and we said it was all those parts. All right.
That makes sense.
Now, I have no idea what that is. I have no idea.
Next slide.
Way different than what we just did. I know what that means. What we're about to do is way different than what we just did.
It looked like Kahoot, Jace.
No, meaning I'm going to give you some data and you're going to find the rate, which we just did. But this is way different than what we just did. Whoa. Why did it just do that? It should have gone there. All right. So this is how we find the rate law using initial rate data. That's what we've been doing. Okay. So if the problem says using initial rates, determine the rate law for, that's what we have been doing. Okay. This is different. This will be the integrated rate laws, and it will use a completely different thing. Whatever. Integrating this, manipulating this equation produces this, which this is the like point slope form or whatever, the y equals mx plus b. I don't remember what that's called. All right, that says line. If we rewrite this equation, it simplifies to this. Not simplifies, but it goes to that. All right, and that's in the form of y equals mx plus b, which means it forms a line. If it's an equation that forms a line, then there are parts of it that can tell me things about the line, or more specifically, if I can plot the line and find some data, it will tell me parts of the chemistry. For instance, what is m in y equals mx plus b? The slope of the line. All right. T is your x, so the slope is equal to negative k. You see that? Can you see that from the equation? It's kind of tricky. But whatever variable's in front of your x, because your time is the thing that's throughout this, so that's your x. The thing in front of it, negative k, will be your slope. So if we can find a line, if we can find the slope of this line, which is rise over run, then we can find negative k. And once we know negative k, we can easily find positive k, and then we can know the rate line. Sort of all right with that idea? It's a little bit weird, but it works out well. All right, now, this only works for a first order process. All right? Now, there's a way to do it for a second order, but it's different math. All right, therefore, if a reaction is first order, a plot of ln of A versus time will yield a straight line, and the slope of the line will be negative k. This is something that you should convert into your memory. Not convert, whatever. Memorize. A first order reaction, the plot of ln of A versus time will yield a straight line, and the slope of the line will be negative k. Now, what's nice about this is I can find the ln of A in my calculator, and I can plot it versus time, and then I can plot it, and if it's a straight line, then I know it's a first order reaction. And if I know it's a first order reaction, I find the slope of that line using my regression linear fit or linear regression fit in my calculator, and that will tell me my slope. I would put more of an arrow here, not really an equal. This is not a math like equation. But if you have your ln of A versus time and then you plot it, You can use that plot to find your data. Then what would your y-intercept be? That's the B part, right? What is this right here? All right, it helps us find the initial concentration. We won't use that as much, but it is usable. All right. Uh-oh. All right, yada, yada, yada. You don't need to write anything here. It's just saying, all right, we're going to use this as our reaction that we're going to do data on. So we take methyl isonitrile and convert it to acetonitrile. Keep doing that. All right. So this is what we have here. This is a plot for the change in concentration. Now, you need to know this from now on. The change in concentration is analogous to, it's not exactly the same, but the change in pressure. So if we do this reaction in solutions, then we'll talk about the changes in molarity. If we talk about the reaction as gases, the thing that's changing is the pressure of the system. So, or the partial pressure of each part. So it will be the same math, but sometimes it will be molarity right here, or sometimes it will be torr. You don't really need to worry besides just knowing which it is and how that might affect your units for the other thing. But anyway, this is your concentration. I keep saying concentration. This is your partial pressure of that versus time. All right? I swear I'm not. Here we go. If we use our calculator and we take this same data and we plot the ln of these values versus time, it yields this line. The first thing you would ask yourself, is that linear? Yes. If this was not a first order reaction, it'd be curved. Okay? It would not be a line. If it's a line, you know it's first order. Now, it already told you it was first order. But now, here we go. The process is first order, and K is the negative slope, 5.1 times 10 to the negative 5 seconds. Slope, once again, you just find 2 points, and you find the rise and the run. Who's with me so far? It's a little weird, but it's doable. Because they're showing you different things. This is your change in pressure over time. That's your, like we would find the instantaneous reaction rate by finding the slope there. This one is taking these values, just the like 150, 130, 125, or 115. It's taking those values, taking the ln of them, and finding them, and then plotting those numbers. Yeah, they are different. Okay, so this is what we're going to do. We're going to try and do one of these ourselves. So you will need a calculator now that you can put data into tables.